My name is Varun. I'm based in New York City. I work at Comm Technologies. Previously, I worked at Amazon, and I'm a fan of long walks, good food, and the arsenal. So yeah, let's jump into it. So at Comm, we have it feels like endless number of languages that we use. We have a React Native app, and as if that wasn't enough, we had to add Java, Objective-C, Swift, Kotlin, C++. And now the question is, Rust? Do we really need one more language? So a little bit more background on Comm. Comm is an encrypted messaging app. So basically, in the endless number of messaging apps today, encryption really only works for simple chat. It's not really geared for communities. So to do something more complicated requires what we call a key server, which is basically a personal application backend that you can use to communicate with the outside world, fully end-to-end encrypted. So basically, this lets us do things like backup, encrypted look ahead, encrypted notifications, etc. P.S. You can DM a show, my boss, if you're interested in trying Comm. So how do we use C++ today? So we use C++ in our React Native app for a multitude of reasons. Some are for encryption. So we use Ohm, which is an implementation of Signal's double ratchet protocol for end-to-end encryption. We also have a database thread. So we run SQLite, and this is where we store, basic user data and stuff like that on the app that we want to persist. And then we have networking. We use gRPC, which is not supported on React Native's flavor of JS. There is a gRPC JS library, but unfortunately, it didn't work for us. So we opted initially for a C++ gRPC framework instead. So quick overview. You probably, since you guys know about React Native, you've probably heard about the JSI. So the JSI is the JavaScript interface, and it's just a way to performantly integrate between C++ and JavaScript. Some stuff happens on the JS thread, but we have separate threads for all of the above. So let's go over some pros and cons of C++. So first pro, it has full support. There's a shared implementation across iOS and Android. Plenty of React Native libraries that are written in C++. It's officially supported by Apple, Google, Meta, and it's a familiar language. I feel like most people, maybe in like an intro CS class or maybe in industry, have come across C++. So, even if there's not always like love for the language, there is at least some familiarity. There are some cons. So the first con is callback hell. So I believe in C++ 20, this is mitigated a little, maybe 17, where now there's async await in C++. So it kind of makes this easier, and you don't have to write a whole bunch of callbacks. But unfortunately, in the version of C++ that React Native ships with, as of 4 months ago anyway, when I was researching all of this, unfortunately, that version of C++ did not support async await yet. And not to mention that upgrading React Native is such a pain that it's probably not worth it, even if it does for most people. Another con, integrating libraries is a big pain. As I'll show you, our CMake lists and our Xcode files were littered with just random dependencies that we had to pull in just to try to get things to work. It felt like developing with C++ in our React Native app was just constantly fighting against the compiler. And the last con that I want to get into is a lack of memory safety. So especially with like younger, more junior programmers, this can be an issue where you might have like a dangling pointer or something like that, and it leads to an issue that we can only catch at runtime after sifting through a stack trace and trying to find what exactly was going on. And especially with the JSI, this is tricky, as I'll get into. So let's talk about callbacks first. So you can see here, this is what our C++ code looked like roughly 6 months ago. So we have this JSI, we have a function that's returning a JSI value. Within that, we have a return create promise as a JSI value. Within that, we're invoking something on the crypto thread. And then within that, we're invoking something on a global DB singleton. And then within that, we have to actually call the JS invoker to trigger something on our JavaScript thread. And all this code it's really tough to wrap your head around. There's a lot of nesting. And some of this can be simplified with like refactoring to reduce the nesting, but you don't get away from fact that you got to keep this like massive stack in your head and unwind it to figure out what's going on, which isn't always very easy. Then let's go over library integration pains. So on Android, you have to download a library and build.gradle, and then there's no standardized package manager for C++. So every library has to be manually downloaded and built for each platform. Similarly, on iOS, you have to download the library in a pod file and then configure the build in Xcode. And we had to do this for gRPC, Olm, SQLite, Folly, Boost, and it's way more painful than it looks. So here's an example of what I'm talking about. You can see when we finally pulled out some of these C++ dependencies to replace them with Rust, how much. So yeah, that just shows you like the amount of garbage that you have to like deal with when integrating a C++ library. It's not very fun. Now, the last and probably most important thing is memory safety. So I have a question for the audience. Can anyone here point out what's going to cause a seg fault in this code? I'll give you a second. It's a little tricky because, a bunch of us also looked at it, and it took actually crashing our app to figure out the problem. All right, this is the issue. So basically, on the database thread, we're trying to call the JS runtime, and this may or may not lead to a seg fault. It's pretty non-deterministic, and it's just no fun to debug. So basically, long story short, C++, it's fine. We think we can do better. So let's talk about JSI in React Native with Rust. So basically, what we've done in our code base and what I'll demonstrate for you today is as thin a layer of C++ code as possible on the native side of the JSI. And then from there, we use this cool tool called CXX to generate Rust bindings to C++. And then from there, we can actually write most of our real logic on the Rust side using the Tokyo runtime, which is just an async that Rust has in its ecosystem. So let's get into it a little more. So we talked about these cons, right? The first one being callback hell. So how does Rust solve this? Rust has async await syntax. And with the Tokyo async runtime, this is very easy to use. There's nothing really that you have to configure. You don't have to handle futures manually or anything. So the next pain point, integrating libraries. Rust ships with Cargo, which is a package manager, but it's also way more than that. And it makes managing dependencies really easy. It makes compiling a breeze. The compile times can be slow with Rust. That's like one drawback, but we found that that is a worthwhile trade-off for us. And the last con, lack of memory safety. Well, that's maybe Rust's claim to fame, is that it's type safe and memory safe. And this is something that every Rust developer will beat to death, but it's worth mentioning, endless times, because it really is such a lifesaver when you don't have to worry about, unless you're writing unsafe Rust, which, is a whole other can of worms. You don't have to worry about memory safety, which is really nice. So let's actually talk about how we can call Rust from C++. So, and then, actually tie that all into our React Native app. So passing the JS promise to C++ is trivial with JSI, but it's a little harder to pass it to Rust with CXX. This is because you can't pass a reference because Rust borrow checker doesn't want us to do this. Therefore, we need some way to manage unresolved promises that are waiting for a Rust task to complete. As you can see here, we have a Rust promise manager. It's been implemented as a singleton that's responsible for managing promises. It keeps a map of promises, of promise IDs to promises. You can see that it's called promises here in the code. And now we can send the promise ID to Rust, and Rust can later send the ID back to C++ via a callback, at which point we can reject or resolve the corresponding promise. And this is what our Rust code will call when it's finished with the computation that we've offloaded to it. This callback function will either call the Rust promise manager reject or resolve method, depending on what's passed to it. So you can see in here, we're using polydynamic. It's just a convenient way to deal with dynamic types in a statically typed language like C++. And now the Rust code. So note the CXX bridge decorator. This is important. This tells CXX that this module, FFI, which stands for Foreign Function Interface, is going to serve as the bridge between Rust and C++. It'll handle generating all the code to get the two to talk to each other. Within this module, we declare which functions will be implemented in Rust within the extern Rust block, and which will be implemented in C++ within the extern C++ block. So you can see the string callback function is written in C++, and we've included it with this include Rust callback.h line. And similarly, we've exposed an add function from Rust that'll be available in C++ as Rust add. So now we have to actually tie it all together. This is the last step. So now we just have to modify our native turbo module add function to call the Rust add function. So here's the old code first. You can see that we're just resolving A plus B. Now the new code. So it's a little more complicated. I'll give you that, but it's not terribly complicated. At least not nearly as bad as the nested C++ that I showed earlier. So you can see what's going on here is we store the promise with our promise manager, and then we pass the promise ID to our Rust add function. So then when Rust finishes the addition, it'll just call the callback, and then the JSI value will be returned to JavaScript. I have a brief demo. So you can, if you're interested in trying it out for yourself, here's the link. But yeah, let me stop screen sharing and pull up the code first. And then actually, I'll pull up the simulator first, demonstrate this. And then I think if we have some time, I can do some live coding so it's not so hand wavy. So here's the simulator. You can basically enter two numbers. Let's do something that people can add in their head. And you can see that it works. But this isn't really convincing. So why don't we jump into the code and try live coding real quick? Yeah, so this is just the front end. Why don't we jump into the more interesting stuff though? Let's go. Let's work backwards. So let's pull up lib.rs. So this is our Rust code. So right now you can see we have Rust add, which is just given two numbers in the promise ID. And recall that we have to keep this promise ID so that we can eventually resolve or reject it with the callback, which is happening here. And then we have like our add function, which is spawning an async task. And then we have this async add, which actually performs the addition. So we could do something, I don't know. Why don't we we'll call this multiply helper. This way we're not changing too many things. Oops, I have a different form. Okay, well, it's just gonna make it ugly formatting. Apologies. Multiply. And we should, so in this, so you can see it's complaining now because it's expecting an add function to be defined in Rust and it's not. So we just need to change this. And we should change the CXX name to the Rust multiply. Now, I think that's it. Now we can go to the C++ code. We'll call this multiply. We'll call this Rust multiply. Again, apologies for the formatting. And yeah, you can see we're doing, everything else stays the same. And we have to update this. Weird that, oh, it did find that one. Okay. We should change this to product. Now, add result, we can call it product or multiply result to keep it consistent. All right. I think that might just be it. Let's try running again. Oh, it failed. Oops. Yeah. And so it was complaining that there is still a reference to add. In the bridging. No, that's not the issue. Oh, I think I just need to like clean the build folder. All right. I think that since I have to clean the build folder, this will take like maybe like a couple minutes. It might be worth just opening up to Q&A and then I can demo our updated app right after.
Okay, I think I'm gonna try and give someone a mic to ask a question. If you can't hear it, I'll just have to repeat it.
I think the gist was, can you just talk directly to C through the JSI?
Correct, yeah.
Yeah, you could do that. So actually though, we tried that. It ended up not being a whole lot better. The thing is, if you think of, C, C++, and Rust as the vertices of a triangle, it's actually kind of an isosceles triangle where C to C++ is a pretty long edge, and C plus, or and then C to Rust is also a pretty long edge, but C plus plus to Rust is fairly short. You know, there's not a whole lot that separates them paradigm wise, aside from the borrow checker. Sorry, I should take that back. There is a lot that separates them, but it's not nearly as much as C and Rust or C and C plus plus. At least that was our experience. And so we opted for this approach where you create like a thin C++ layer and then try to write the bulk of your logic in Rust. I'm sure that others have tried it with just C, and then, yeah, you can use, there's like C bindgen and some other tools that you can use to then call Rust from your C code.
Did you ever consider just doing crypto and things you're going to do in C++ just in JS? Was that feasible for your projects? Like, why did you choose not to do that?
It was doable for some things. For instance, there is an implementation of Matrix's Olm library in JavaScript or in TypeScript, I think. Ultimately, there are a couple of things that made doing it in native more appealing to us. One was that we wouldn't block the JavaScript thread for some of these things. You know, cryptography, a lot of the operations can be pretty expensive. And so we saw the app's performance deteriorate significantly when we tried to implement some of the crypto stuff in the JS thread. So moving it to its own native thread made a lot of sense for us. It significantly improved the performance of the app.
Okay, I think that's all for questions, Varun. Are you going to go ahead with your demo now, or?
I think it's not.
Okay.
Let me see what's going on. 1 second. I thought I would have completed by now, but let me share my slides again. You can grab the link to the repo and try it out for yourself. So this is the link to the repo. You have to, when you do the pod install, you have to use the you have to set like a new architecture flag, but that's pretty easy to see in the pod file. And then if you want to connect, here's my GitHub and my Twitter, or X, I should say. But yeah, thank you so much for having me. You know, it's been a pleasure and really enjoyed the talks before. So keep it up. And I look forward to seeing what you guys do in the future.
Nice. Thanks, Varun.